Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be looking at algebra, and then under algebra we will be doing revision on exponents, SURDS, and logarithms, grade 12. Remember to send your clarity seeking question to our WhatsApp number 079-578-2908. I'm repeating, the number is 079-578-2908. Now, grade 12, at the end of the lesson, you will be able to simplify exponential expressions, solve exponential equations, add, subtract, multiply, and divide sets, simplify logarithms expressions, solve logarithmic equations. Now remember, before you do any exponent simplification, you must be able to apply the rules of exponents. Thereof, we have different rules under the exponents. The first one, we are having the product rule, of which it is saying now if you have a to the power m and a to the power n, that means you are multiplying the same base here. Multiplying the same base, the rule says that you add the exponent. As you can see, you take only one base there and then you add the exponent, grade 12. So rule number 2 is a quotient rule. It says when you are dividing the same base, you subtract your exponent. As you can see, we have subtracted m and minus n. The same here, we can have the notation a to the power m over a to the power n is the same thing because it's the division application. So you still end up with a single base a and then subtract your exponent. Okay. And then the power of the power rule, that means you are having two exponents now on the same base. So you have only single base a, but it is having exponent m, and then again the whole power is to the power n there. So now just remember that the bracket symbolizes multiplication. That means you'll be having a to the power m multiplied by n there. Remember, there's a multiplication sign between those exponents. And then the power of a product rule, that means you're having two bases now of which they form a product because it's a times b, but they are now sharing the same exponent m. It's like two children of the same family now. They will both take this name here. So that is why we end up with a to the power m and the b to the power n. It's Alina and Betty belonging to the same family. So it's Alina Mutawung and the Betty Mutawung. So both children will be taking the same name. The same applies with the power of the quotient rule, grade 12. This one, because it's the quotient, is an answer that you get when you divide. So you'll be dividing your bases. As you can see, it's a over b. But still, both of them, even though they are dividing, they are sharing the same exponent m. So each will take the exponent a to the power m over b to the power n. And then we have the zero exponent rule, and then any number raised to the power 0, it is equals to 1. You must ensure that this number here, it doesn't matter how big is the number. It can be 200,000, grade 12. As long as you take this number and you raise it to the power 0, this will just become a 1. It loses the value to 1 now. Okay. And then now the negative exponent rule. This means now you are having a negative on your exponent or on your index. So that means now here we have an exponent with a negative. So this will become 1 over a to the power m, of which is the same exponent. But look at this now. After forming a fraction here, that negative does not appear anymore on your exponent there. Okay, that simply means now if I'm having 2 to the power minus 2, this will be equal to 1 over 2 to the power 2, of which is 1 over 4, great trust. And then fraction exponent rule. So with this one, you are having a fraction on your exponent. We call it rational exponent. And the rule says that if you are having this rational exponent, you can write this in a sad form. That means the n below there goes to your root sign there. And then this is forming that square root there. And then a will remain with its exponent n there inside your sad form or your root sign. Great jobs. Okay, vice versa, you must be able to take it from the root sign to the exponential form. Either way, great jobs, you must be able to change your expression, okay, according to this rational exponential rule. And then we have laws for sets. We cannot solve for sets if we are not applying these rules. Every root is having its rule. You can't write something that is out of this root K12. So now with the third rule, it says that if we are having, because it says everything will be in a root sign. So now the nth root of a is the same as a to the power 1 over n. Can you see now is that exponential rule that we were talking to lastly? We were taking this to the set form. Now we are moving from the set to the exponential rule now. Same applies there. Remember why? This a is a to the power 1 there. So it remains a to the power 1. Can you see that? The one that is on the root sign, the one that is becoming your denominator on your exponent today. Moving to the next rule now, we are having the nth root of a times b now. So this rule is saying to us, as long as you are multiplying inside there, you can separate this with a multiplication in between. So each base will take this root sign, the nth root of a multiplied by the nth root of b. They are sharing the same root sign there. You can separate them. Why? Because they are multiplying. That is not the case, grade 12, with if you are having the nth root of a plus b, you cannot separate and say this is the nth root of a plus the nth root of b. That is not the same case, grade 12. You can only do this if you are having a multiplication in between. And then rule number C, we are looking at the nth root, and then this is now the quotient. As you can see, it's a division there. So now each and every of this can say take the nth root. As you can see that the a have taken its nth root with the division line, b have taken the nth root. You can even move it reversely, so from this point to that one. We are more than welcome to do that. But you can only do this two when you are multiplying and dividing only. You cannot have maybe the square root of the nth root of a minus b, and then thinking that grade 12, you can write this as the nth root of a minus the nth root of b. This is not allowed, grade 12. You can't apply that. It's only applicable for multiplication and division. And then number D, you are having the nth root of a, and then this root is having another exponent n there. And then now they say the answer is a. How did they get that a now? Let's see what is happening here. We are still applying the exponential application versus the third. Remember now, this a is a to the power 1. We are taking rule number 1 there that says if we are having the nth root of a to the power 1 is the same as a to the power 1 over n. Okay, in this case now, this nth root of a is having another exponent n. Oh, that means this is having exponent n. This will also have exponent n. So what happened is this is n over 1. So n will go once there. So that finally we have an answer that is a to the power 1. That is why this rule is saying that. Okay, this simply means now, if you are having the cube root of 2 to the power 3, this is your answer will only be a 2. That is what it means. If the number there in your root sign is the same as your exponent, that means your final answer will be what is inside. That is the application of the said rule, because the exponent is the same as the nth root. The answer will be what is inside your root sign. And then number E, we are having 2 now. Application of set is the nth root and the nth root of A. The base is only one base, but is having 2 root signs, the nth root and the nth root. So that means now you can take this A into only single root sign there. And then now you multiply these 2 on that particular set or root sign that you have created, grade 12, so that this can belong to only one set. Okay, that is the application we are talking to. And then lastly, we are having the nth root of A, and then this is now having a different exponent when compared to that one. That is not the same as that one. In this condition, the n was the same as the exponent. So here they differ. That simply means now grade 12, oh, this m can go in here and become the exponent for m, for A base A, sorry, for base A. Okay, so you can have your nth root, but now this m is moving into A there, and then this will be A to the power n. So that is the root on set. And then now logarithms law, can you see now all the topics that we'll be dealing with today, grade 12, we will be applying rules and laws of those particular topics. And then now we look at the logarithmic laws. With the logarithmic, now we are having the log of xy base A. And then now if you are multiplying your logs here, that means now as a single log, you can separate this and create 2 logs of that. If they are multiplying, they will now add this side. Okay, and that will be the log of x base A plus the log of y with the base of A. So if you are dividing from a single log, you'll have 2 logs now, but because of division, this will be subtracting the log of x, of which is the top one, minus the log of y. Or grade 12, again, this notation here can be given as the log of x base A divided by the log of y inside the bracket like that. You must know that we are talking to the same thing, so you apply the same application. And then with the log of x to the power n base A, this rule states that you can remove this exponent and take it as the coefficient of the log. That is why we end up with n log x base A. Okay, this will be mostly applied, grade 12, when we are doing our examples. You look at that when you are doing our baseline assessment then. In this one now, look at this. We are having the log of x base A. We want to apply change of base. Some of the questions will be emphasizing the application of this, or be in need of using the change of base in order to solve your problems. So now why do we call this a change of base? It's because we're having base A there with the log of x. Now we are changing this into log x base B over the log of A base B. The aim is to make sure that we have same bases there. That is the aim of the change of base. Okay, this simply means now if we are having this division grade 12, we can reverse and write it as a single log of the log x with the base of A, and then you just get rid of the log of B there. Okay, we'll see when we are doing activities on this. We will elaborate more on these applications. And then the next law, if you are having the log of A base A, can you see that the log is the same as your base there? So this will be equal to 1. That simply means if I'm having the log of 10, remember they normally don't write that 10 there. This log 10 base 10 is equal to 1. It simply means if your log is the same as your base, then this will be equals to 1. And then the log of 1, it doesn't matter what the base is, as long as it's the log of 1, the answer will be 0. It can be the log of 1 and the base of 20. As long as it's a log of 1, the answer will be a 0. Great job. That is what this rule is stating to us. Okay. And then now we have terminologies that we are using under exponents, under sets, and under our logarithms. So now, as I was talking to the base and the exponent and so forth. If we are taking the whole expression here, this is the power. That is the whole power. Okay? And then now these 3 here represent the base. Any number that is noted here will be your base. And then the one that will be up there will be your exponent or your index. Okay? That is the words or terminologies that we'll be using. If we say base, we must know we talk to that. When we talk exponent, and then we talk the power, is the whole item now. And then now when coming to set, a set is the root of a whole number that produce an irrational number. For example, if we look at the, what does this mean now? If I'm looking at the cube root of 8, we know the cube root of 8 is equals to 2. Therefore, this is not a set. It will be a set if it gives us a rational number. For example, the square root of 2, it's 1 comma something, that is a set. Okay? Yes. That is the root signs that we refer as being the set. They are the ones that are producing irrational numbers. And then now moving to the logarithms. A logarithm is having a relationship with the exponents. In mathematics, that is why they are having exponential functions and the log functions, because one is the inverse of the other. So now, unfortunately, technical mathematics, we only have the exponential function. So with the logarithms now, in relation to your exponent, now remember now, this is exponential notation. A to the power x equal to y. Is your equation in exponential. It's an equation of an exponential function. Do you still remember that on your function? Now, this can be written as the log of y base a equal to x. That means we are using this method if we have something that you need to calculate being on the exponent there. In order to bring down this x, we are going to apply this rule. What is happening here is now, if I'm having, let me take this again, a to the power x to the power 1. Let's say we are solving for that x now. We can bring that x down. But the minute we bring it down, we are creating a log on the other side. That will be log of y. And then this a now become a base on this log. That is what is happening there in comparison to an exponent and the logarithms. So they are sharing that relationship. Okay. And then this a must always be positive value here. Our base must always be positive. And then a must not be equals to 1. Because why? The log of 1, do you still remember, it's 0. And then y must not be equal to 0. Okay, then we are having examples here of changing an exponential to a log. Okay, can you see now we want to bring 5 down here? We know mathematically that 2 to the power 5 is equal to 32. That is true. Okay, if we want to bring this now and write it in a log form, we bring 5 down. There we have it. And then the minute we do that, we put a log on the other side. As you can see, this is log of 32. And then that 2, which was a base, will still be a base on the log there. So that is the playing around of the logs to exponential, exponential to log. Okay, great jobs. There we have your baseline assessment. Baseline is the activity that we do for the pre-knowledge that we are testing whether Do you have all the information needed before we can start with the new activities of today? So let's go through the baseline assessment on your own. I am giving you 3 minutes to give us the solutions to these 8 basic information that we need before we can continue. 3 minutes for this one, starting now. Okay, great chance. Remember to send your solutions and what you like to share with us to our numbers 079-578-2908 or any clarity seeking question to that particular number. Now let's look at the first baseline question then. We have 3 to the power 3 multiplied by 3 to the power 2. I think you still remember your rules because you can't do this without applying your rules correct. So it's the same base 3. And then if you are multiplying, we will add the exponents. That will be 3 plus 2. Then we end up with 3 to the power 5, of which is how much, grade 12? 3 to the power 5. That is the 32. Okay, happy? And then the second one, we are dividing. We apply the rule that is saying now when you are dividing the same base, we do what? You subtract exponents. It will be 2a plus 3 minus the exponent a minus 3, which is equal to the same base 2. Then we remove the bracket there, 2a plus 3 on our exponent. This will be minus a plus 3, of which we end up with 2, same base. And then now we add like terms on the exponent is 2a minus a, which is a. And then you have a 3 plus 3, which is a 6. So that is the answer for that. For number 3, can you see that we have multiple exponents then. So now remember we said the minute you see that bracket, you must know that there is multiplication of those exponents. Then it will be 2 times 3, of which is 2 to the power 6. Then this is giving us a 64. And then now number 4, we are having two different bases, but these two are sharing the same exponent. Same children sharing the same surname. So it will be 2 to the power 2 multiplied by 3 to the power 2, of which is giving us the 4 times 3 squared is the 9, and then 9 times 4, or 4 times 9 is equal to 36. And then number 5, again, we have A over B, the quotient, because we are dividing, but both of them are sharing the same exponent 2. So it will be A to the power 2 over B to the power 2. And then number 6, now it's where we are involving our sets. Remember we said this x to the power 6 will remain like that. And then this 3 now will form a fraction there over 3 on your exponent. So this is a 6 over 3 exponent. Therefore, this will be x to the power 6 divided by 3 is a 2. Then this will be x squared. And then number 7 now, again, you're having a quotient because we are dividing. And then now each will take exponent. But unfortunate part here is that our exponent is now negative. Then it will be b to the power minus 2 over c exponent minus 2. Now, if it's an exponent, you still remember that we said if it is 2 minus 2, this will be 1 over 2 to the power 2. Can you see that 2 to the power negative change a position from a numerator to the denominator so that the exponent become positive. So we are going to apply that now. This b minus will go below and the c will go up there. Then we'll end up with c squared positive and the b squared positive there. So now just move the position numerator to denominator, then it will impact on your exponent and change that. Any number to the power 0, the answer is 1 greater. Doesn't matter we have 100 inside our bracket, but the whole base is 100a. So the whole thing is raised to the power 0, therefore it's equal to 1. Or you can say each is taking an exponent 0 multiplied by a to the power 0. 100 to the power 0 is 1. A to the power 0 still 1. You will still end up with an answer 1 there. Okay. And then the second baseline now, on the third, I am giving you 2 minutes on this one. Your 2 minutes, that's now grade 12. Let's see how much you know on third before we can start with the activity of the day. Okay, great job. Let's see how far did you go with this one. Remember the third rules, it says that when you are multiplying this, you can write this as a single third and then multiply your numbers in there. So here we are basically looking at the square root of 6. Okay, and then the second one, we are having the square root of 27 over 3. And then with this one, you can start by dividing, because it's possible to divide 27 by 3, of which it goes how many times? 9 times, great terms. And what is the square root of 9? That is 3. Or you can write this 9 as 3 squared, and then into the square root sign, so the square will cancel the 3. The square root sign, you'll be left with the 3 there. The 2 will cancel the square root sign, therefore you'll be left with the 3. That is why we are saying the square root of 9 is equals to 3. And then the next question, number 3, we are multiplying square root 3 times 3. That means we are having square root 3. How many of them? 2 squared. So can you see now we have created again exponent 2 there. It will cancel the root sign. The answer will just be a 3 there. Okay. Any number grade 12, as long as you are multiplying the same thing, the answer will be a. Because now the square will cancel the square root sign there. And then number 4, we have 5 square root 3 plus 2 square root 3 minus 3 square root 3. So that means it's like adding the same thing, because you are adding 5 square root 3 plus 2 square root 3. So you end up with how many square root 3s? 7 of them. So it's 7 square root of 3. Then we subtract 3 square root of 3. So out of 7 square root 3s, you subtract 3 of them. Then we'll be left with 4 square root of 3. So that is our answer. Okay. And then with number 5 now, we cannot solve this without writing this in a simple set form. How do you do that? Because we are answering these questions without using a calculator, creators. You are not allowed to use a calculator. And then now you look for the square root of 12. Now, 2 numbers that you multiply, that will give you a 12. One of those numbers must have a square root. Okay. So which are those 2 numbers? That is 4 times 3. 4, 8, 12. Okay, so you write this 12 as the square root of 4 times 3 plus 475. 2 numbers that you multiply give you 75. One of it must have a square root. That is 25 times 3. And then this will give you a 25 times 3. Can you see you have created something common on both, which is square root 3, square root 3 there? There must be some link in terms of your creation there. And then now we can take out from this one the square root of 4, because we know square root of 4 is 2. So it will be 2 square root 3. Plus for 25, we know square root of 25 is 5. Then it will be 5 square root of 3. Then we can bring in the addition now. 2 square root of 3 plus 5 square root of 3. So we are adding 2 square root 3 plus 5 square root 3. That will be 7 square root 3s. Okay. And then now moving to number 6. This 2 means 2 bracket of this. Then we are multiplying 3 minus 2 square root of 2 with another 3 minus 2 square root of 2. This 2 means bracket of the same thing, Rachel. It's not difference of 2 squares, no? It's the bracket of the same thing. 2 brackets of the same thing. So now we are using distributive law. 3 times 3, which is 9. And then 3 times minus 2 square root of 2, that will be minus 6 square root of 2. And then we come to the second term now in the first bracket. Minus 2 square root 2 times 3, that will be minus 6 square root of 2. And then minus 2 times minus 2 square root 2, that will be positive 4. Remember, we are multiplying a negative 2 times a negative 2, which is giving us 4. And the square root of 2 times square root of 2, which will give us a 2. And then now simplifying that further, it's a 9. Remember, this will give us 8. Therefore, it will be 9 plus 8, of which is a 17. And then minus square root 2 minus square root 6. Minus 6 square root 2 minus 6 square root 2, it will be minus 12 square root of 2. That is the answer, grade 12, for that one. I hope you managed to reach that point. And then now let's take the last baseline. I am also giving you 2 minutes on this one. Okay, grade 12, let's check now. With the logs, a base plays an important role. That is your key. Always look at the bases to direct you. Here we are having base 4 for both of your logs that are given to you. And then remember now, if you have the same base, you can write this as a single log of base 4. And then now, because this is addition, it will be applying the multiplication of your logs. So this is equal to the log of 8 times 2, 16 base 4. And then we are going to write this 16 as the 4 to the power 2. Log of 4 squared, that is still a 16 grade 12, right? With the base 4. And then you apply the rule that says you can take 2 to the front. That will be 2 log 4 base 4. And then now the rule that says if a log is the same as the base is equals to 1, and then 2 times 1 is equals to 2. Okay. And then the second one now is the division. Now it's a single log. We must separate it back to its logs, 2 of them, because this is the division of 2 numbers there. So since it's a division, it will be a log of base 2 of 40. If it's a division, it will be minus this side. Do you still remember that, grade terms? Okay, or we can write this. Okay, let's take another method, the shortcut one. It's a log of base 2, and then we have 40 over 5. And then if we divide 40 by 5, we'll be having log of 8 base 2. This is much better. And the log of 8 base 2, now you can see that we are controlled by this base 2 here. You can write this 8 with a base 2. So that will be log of 2 to the power 3. You have a base 2 there, which is now taking 3 to the front. That will be 3 log 2 base 2. And then that will be 3. A log of 2 base 2 is the 1. Then 3 times 1 will be 3. Moving on to the next one, our base is 10, 10 here. Write as a single log. This will be log of what? We are subtracting, it will be 20 over 2 in terms of the division now. as a single log, okay? And then now log of 20 divided by 2 is 10. Remember, because if there is no base here, your base is 10, okay? So that is the log 10 base 10, of which will just be equals to a 1. Finally, we are looking at that one now. With this one, we have a challenge because the bases are not the same. So we need to apply the change of base. Change of base is the rule that is saying the log of 49 over the log of 3. The first bracket, second bracket will be the log of 27 over the log of 7. Okay, and then on top now, grade 12, you can write that in terms of the base of 7. That will be 7 squared. Remember, 49 will be log 7 squared over log 3. So 3, you can't do anything to that one. And the log of 27 is the same as log of 3 to the power 3. Log of 7 is also already in a simple form. And then now we apply the rule that is saying 2 to the front will be 2 log 7 over log 3. And then this one, 3 to the front, it will be 3 log 3 over the log of 7. Because we are multiplying, because of those brackets, we are allowed to say log 3 divided by log 3 goes once, log 7 goes once into log 7 there. And then your answer will be 2 times 3 that is remaining, which is equals to a 6 grade 12. So that is the expected solutions for this particular baseline. And then now we are going to the real situation, the exam type questions now. And then now we are looking at the exponents first, multiplication and division. Grade 12, you must be able to tell as looking at the question whether it's a multiplication and division question or it's an addition or subtraction question, because the method is not the same there. And then now they say simplify the following expressions. Number 1, we are giving 2 to the power 2n plus 4. Multiply, this dot means multiplication. 2 to the power 2n minus 2, and then 2 to the power 2n plus 1, multiply by 2 to the power 2n on the denominator. Numerator is on top, denominator is down, denominator below. Okay, now with number 1 now, we are fortunate enough because we have the same base throughout. We have checked, yes, it's the multiplication and division type. Therefore, we are going to apply the exponential rules for multiplication and division. It says when you multiply the same base, you add exponent. When you divide same base, you subtract exponent. That is the application. So now you need to check, do we have the same base? Yes, everything is in terms of base 2. That is very easy. We are going to take that base as being the single base because it's the same throughout. Why? Because we are multiplying and dividing. Okay, single base. On top, because they are multiplying, they will be adding 2n plus 4 plus 2n minus 2. Basically, you are writing everything on top as it is greater. And then the ones that are on the denominator, when they come up now to the exponent on top, we will be subtracting. This 2n will become minus 2n. 1 will become minus 1. 2n will become minus 2. Everything is changing its sign now to the top exponents. Okay, and then now we end up with 2. We now check like terms. 2n plus 2n is 4n minus 2n, 2n minus 2n, 0. Or you can say 2n minus 2n, 2n minus 2n, it's a 0 there. And then now we come to numbers. 4 minus 2 is 2. 2 minus 1 is a 1. So the answer is 2 to the power 1 for the first expression there. And then let's move to the second one. If we look at number 2 now, we are working with 2 bases. Yes, we are still on multiplication and division. The only difference is here we have base 3 and base 5. But at least everything is in terms of base 3 and base 5. When we work with exponents grade 12, you must ensure that you are working with the prime bases. What do we mean by prime bases? Prime bases are the bases formed by prime numbers. What are the prime numbers? Prime numbers, set of prime numbers starts with 2. You can't take 1. You start with 2. It must be a number divisible by itself and only divisible by 1. Then that number is a prime number. So 2, yes, we can divide 2 by 2 and by 1 only. Okay. 3, yes, we can divide 3 by 3 and by 1 only. Can you take 4? No, because 2 can divide into 4. That is why 4 is not a prime number. It can be divided by itself and 1 only. Okay. And then now 5, yes, we can take 7, yes, we can take 11, yes, and so forth. Those are the basic prime numbers that we'll be using. So when you are dealing with the exponents now, ensure that you write everything in terms of those bases. Lucky enough for this one, it is already on base 3 and 5. Happy. So now we can start. Take the first base. This will be equal to base 3. Now we consider the base 3 only first. Okay. That will be 3x plus 5 on top. And then the one below here, when they come up, it will be minus 3x minus 2. Then you go to the next base, which is 5. And then base 5 on top is having exponent x minus 3. And then this x, when it moves up there, it will be minus x. Now simplifying further, grade 12, you now check the like terms. That will be base 3. And then 3x minus 3x is 0. And then we have 5 minus 2, which is 3. Multiply by base 5. And then x minus x is 0, so we are left with minus 3 as your exponent there. And then 3 to the power 3 will be 27. And then now, do you still remember the rule that when you are having negative on your exponent, you write it as 1. And then you have denominator 5 with a positive exponent 3. That will be 27 multiplied by 1 over 125. So your answer will be 27 over 125 for that problem, grade 12. So that is the simple form of these expressions. And then we are still on multiplication and division. Remember, we said we are using prime bases, of which is 2, 3, 5, 7, 11, 13, and so forth, right? Now, if you look at this problem number 3, we are having base 6 is not a prime number. We have base 10 is not a prime number. We have base 4 is not prime. 15 is not prime. So the first thing that you need to do, grade 12, before you can consider multiplication and the rules, you must write your bases in prime bases. And then automatically they will create something in common in terms of their bases. Now, let's continue. How can you write 6 in terms of the base, prime base? You can write it as 2 times 3. 2 times 3 is still a 6, grade 12, okay? And then now the exponent, remember it was n plus 2. We keep the exponent. And then we are multiplying with the next term. Now 10 can be written as 5 times 2. Everything must be in prime base, grade 12. The exponent is n minus 2 there. And then all over 4, it can be written as 2 squared or 2 times 2. Then it is now in a prime base, multiply by 15. 15 can be 5 times 3 or 3 times 5. They are now in prime base, exponent is n minus 2. Happy now, can you see that you are working with base 2, base 3, and base 5 for this type of a problem? Everything is now in terms of the prime bases. That is your starting point. And then now, secondly, now we are going to remove the brackets throughout. So each child is taking the surname. Do you still remember the rule? Each child is taking the surname. So each base here, 2 will take n plus 2, and also 3 will take n plus 2. And then moving to the next bracket, now each child 2, n minus 2, and then we have 5, n minus 2. On the denominator, remember, if we are having 2 exponents, is 2 times n That will be 2 to the power 2n. Can you see, grade 12, we are busy applying the rules. You can't come up with your thing. You apply the rules that we have explained initially then. And then we have two bases sharing the same exponent. It will be base 3 taking exponent n minus 2 multiplied by base 5 taking exponent n minus 2. Now we have removed all the brackets. So we can now simplify this. Take the first base, base 2, then we will be dealing with 2. Where we have base 2, base 2. Do not mix up grade 12. When you talk to base 2, you talk to all exponents of base 2. So the first exponent is n plus 2, followed by plus n minus 2. And then this one, because it's on the denominator, when it moves upwards, it will be minus 2n. Done with the 2. Now we move to base 3. With base 3, we have n plus 2. Another 3 is this one. We have n minus 2, but now it is moving from denominator to numerator. The sign will change to minus n plus 2. Multiply by base 5. With base 5, we have n minus 2 there. And then this one is moving up. It will be minus n plus 2. Then we are done with the fraction. Now everything is linear position. And then now we can now look for the like terms. So for base 2, we have n plus n, which is 2n. 2n minus 2n is 0. Therefore, we end up with the 0 for the n's. And then we have 2 minus 2 also giving us the 0. Then you must put that 0, grade 12. So you can't just leave it as 2, because the minute you leave 2, you are telling us the exponent is 1. So if it gives you a 0, please put that 0 on the exponent. And then now multiply by, we are moving to base 3. With base 3, we have n minus n, it's a 0. And then we have a 2 plus 2, which is giving us a 4. Multiply by 5. And then with 5, we have n minus n, which is a 0. Minus 2 plus 2 is also 0. Then it's 5 to the power 0. So our answer will be 2 to the power 0. Do you still remember the rule? Any number to the power 0 is 1. Times 3 to the power 4, 81. Times 5 to the power 0 is 1, of which is equals to 81, grade 12. Okay. So now, exponents, addition and subtraction. Previously, we were only looking at multiplication and division. We were applying the first two rules of exponents, of which talks to addition and multiplication. Talking to multiplication and division. Now here we are talking addition and subtraction. The method is different. You can't do whatever we were doing previously. For this one, the method is common factor method. And then how do we apply this common factor? By looking at your expression, you will be automatically seeing something common there to show that this is a common factor method. And then it must be in addition or subtraction. There must be plus or minus in your division of terms. Then you must know you are applying this method. So the first thing that you do is you separate the exponent. Ensure that each base is having only one exponent. So this will be equal to 2 to the power x, 2 to the power 1, plus 3, 2 to the power x. So we are reversing this to its original. And then now we can take out what is common. And then this will be equal to common factor 2 to the power x. Then now when you take out 2 to the power x here, you are left with 2. Plus you take out 2 to the power x, you are left with 3 there. Then this will be 2 to the power x into 5. So now this will be 5, 2 to the power x. Or you can leave it there, it's fine with grade 12. So that is how you solve the addition and subtraction. Can you see? It is applying a common factor method. The same applies here. Can you see something common there? Can you see that? you are having something common and there is a subtraction there. So, but before you can take out that 3 to the power x as a common factor, you need to separate your exponents. Easy separating. Everything now you have separated is having only one exponent. And then from there now we can now take out the common factor on top. When you take out this, you are left with 3 squared, of which is 9, correct? When you take out that one, you are left with 1. You cannot say there is nothing left there. That will be minus 1. And then 3 to the power x is also common on the denominator. Therefore, if we take it out, you are left with 3 there. And then 3 to the power x taken out, you are left with 3 to the power minus 2, which is 1 over 3 squared, of which is 1 over 9. And then the 3 to the power x will cancel or divide into 3 to the power x1. And then on top, we are left with 8. 9 minus 1 is 8. And then divide by 3 minus 1 over 9. That will be 9. 18, 21 minus 1 will be 20 over 9. And this will be 8 multiplied by 9 over 20. Great 12. And then from here now, you end up with the answer. That is 8 times 9. Okay, let's say 9 times 10 is a 90. And then from 90, that will be 81. 81 over 20, there will be your answer. Okay, and then that is how you simplify this expression. I hope now you can see the difference in terms of solving multiplication and division and addition and subtraction now. The difference is this: in this one, we apply common factor method. Okay, and then now we have exponential expressions activity for you, grade 12. I am giving you a 5 minutes to do this activity, and then after 5 minutes, we will be reflecting back the solutions. Okay, grade 12, let's check how far did it go. Remember our WhatsApp number 079-578-2908. You can send all your clarity seeking questions to that particular number or any alternative solution that you'd like to share with us. And then now simplify the following exponential expressions without using a calculator. So do you still remember the method? You check first, are you multiplying, dividing, or subtracting or adding? And then if you look at the first one, it's a multiplication type. Therefore, we apply the rule, same base, we add exponents, okay? So now look at the bases. Are they in prime base? Yes, happy now for this one. It's easy for us because everything is in base 3. So on top, we are adding exponents. And then the denominator one, when they go up, they change sign. Minus x will be plus x, plus 2 will be minus 2. Base 3. And then we now add like terms, x plus 4x, 5x plus x, 6x. And the 2 minus 2 is a 0. Therefore, that is your answer for the first one. And then moving to the second one, yes, we are still multiplying and dividing, but we have a challenge because bases are not the same, and then 6, 9, and 27 are not prime bases. So we must write everything into prime base. So 6 we are going to write as 2 times 3, exponent x plus 1 for both, multiply by 9, we'll be writing exponential form, 3 squared is 9, and then x minus 1. Divide by 2, we leave it like that because it's already at a prime base. Multiply by 27 is 3 to the power 3, then to the power x. Happy now, everything is in prime base. This is creating now that you are working with base 2 and base 3 on this problem. So now first, the next step, we remove brackets. Each child take the surname, it will be 2 to the power x plus 1. Multiply by 3 to the power x plus 1. Multiply, we move to the next one. If we have 2 exponents, you distribute this one to that one, multiplying out. That will be 2 times x is 2x. 2 times minus 1 is minus 2. To the denominator, this one we leave it like that. And then now multiply 3 to the times x, it is 3 to the power 3x. 3 exponent 3x. Right, we now have our bases, no brackets. We can start now taking the first base 2, and then on top we have x plus 1. We consider only base 2, and then on the denominator x plus 1 we change to minus x minus 1. Multiply by base 3 now. We have x plus 1 on top plus 2x minus 2. Nothing is changing, but this one, when it moves up to the numerator, it will be minus 3x. Happy now? This is in linear form. We can now add the like terms for base 2. That will be x minus x is 0. 1 minus 1 is 0. So we write that 0 that is remaining. And then multiply by, we take base 3. It will be x plus 2x, which is 3x minus 3x, give us a 0. And then now we are left with 1 minus 2, which is minus 1. 2 to the power 0, 1. Multiply by, get rid of negative exponent, it will be 1 over 3. So our answer for here is only 1/3 because 1 times 1/3 is 1/3. Move on to the last one. With this one, we don't have a problem because our bases are already prime bases. But look at the method now. We are subtracting. The minute we are subtracting, we are bringing in the common factor method, okay? Now, which common factor we're targeting now, we can see is 3 to the power x throughout there, okay? We can't do that. We can't take out the common factor before we simplify our exponent back to original. This will be 3 to the power x and 3 to the power minus 2. Separating exponent, and then we have 2 there, we have 2 to the power x and 3 to the power minus 2. Take out our common factor on top, 3 to the power x. What is left on this term is 2 minus, here we are left with 3 to the power minus 2, of which is 1 over 3 squared, which is 9. Okay, on the denominator, 3 to the power x, then you are left with 2 times, remember, these are dots, they mean multiplication. You can't bring plus or minus where we don't have a plus minus. In this case, on the denominator is multiplication. It will be 3 to the power minus 2, of which is still 1 over 9 there. Then the 3 to the power x cancel 3 to the power x. And then we have 2 minus 1 over 9. That will be 9. 18 minus 1, that is 17 over 9. And then divide by 2 times 1 over 9 is 2 over 9. And then this is 17 over 9, grade 12, because it's without using a calculator. So when we change this division sign to multiplication, it will affect this part. It will become 9 over 2 now. And then 9 goes once into 9. The final answer will be 17 over 2 for that one. Okay. And then now we move to exponential equations. We are solving for x now. And then now with exponential equation, we have a rule that we are applying. We did it earlier on. If I'm having a to the power x and a to the power y, we must ensure you have single base on both sides, but those bases must be exactly the same. If that is the case, you can equalize your exponents. Therefore, x can be equal to y. Only if you have one base and then they are the same. Okay, that is the application here. So now we have 27. We are going to write that 27 as 3 to the power 3 because we need what? Same base on both sides. So if we have same base, we can equalize the exponent, grade 12. We are not dividing by 3, grade 12. We can't do that. Okay, this is not algebra question 1. You can't do that. This is not the same as 3x equal to 27. Okay. Now it's 2 to the power x. On the left, right-hand side, we have 1. We must write this as base 2 because you can't apply this law when the bases are not the same. Then this will be 2 to the power 0 because 2 to the power 0 is still 1. Happy? Therefore, x is equals to 0 for that one. And then moving to number 3, we need prime bases. Okay, we know that 8, we can write it as 2 to the power 3. So if this is using base 2, this must also use base 2 this side. What is 1 over 4 in terms of base 2? It will be 2 to the, because it's a fraction, that means the exponent is negative. Do you still remember the rule, grade 12? That will be 2 to the power minus 2, but it is having another exponent x there. Therefore, we end up with 2 to the power minus 2x. On the right-hand side, we have 2 to the power 3 for 8. Now, same base, equalize exponent. Minus 2x equal to 3. We divide by minus 2 both sides. Therefore, x is minus 3 over 2. That is your solution. Okay, we are still solving for x. For another question, look at this. We have base 3 and base 2, which is to the power x, equal to 192. There is no way, grade 12, that you can solve this if we have two bases on the same side. So we need to remove those bases by dividing both sides by 3 here, because 3 doesn't have exponent x. So 3 will cancel x, will be left with 2 to the power x, single base. And then 192 divide by 3, we end up with 64. So now we want prime bases. This will be 2 to the power x, 64 will be 2 to the power what, grade 12? To the power 6. Same base, we equalize exponent. X is equal to 6. Same application throughout. With this one now, we are having 25. Now we transpose, this is 1 plus 3x exponent equal to 125. And then 25, 125, those are not prime bases. So we need to change this. 25 will be 5 squared. And then we have 1 plus 3x as exponent. 125, 5 to the power 3. And then now we remove the bracket, 5, 2 into that is 2 plus 2 times 3x is 6x. equal to 5 to the power 3. Same base equalize exponents. 2 plus 6x is equal to 3. So transpose 2 to the right hand side, it becomes negative 2. 3 minus 2 is 1. Divide by 6 both sides because x is not an exponent in this case now. So x will be 1 over 6. That is the solution for that one. Moving on to number 6. We are having different bases as you can see there, grade 12. But you still remember that if you are adding and you have common factor there, we can apply the common factor method on the left. So now let's do so grade 12. So you are having 5. We start by separating exponents first on this base 2 here. That will be 2 to the power x and 2 to the power of 2 equals to 68. Common factor 2 to the power x. So when you take out 2 to the power x on the first one, you are left with 5. Plus 2 to the power x, you are left with 3 times 2 to the power 2 of which is 4 equals to 68. Then you have 2 to the power x, and then we have 5 plus 4 times 3 is 12. 12 plus 5, that is 15. 17, sorry. 12 times 5 is 7. Is 4 times 3, 4, 8, 12. 12 plus 5, that is 17, equals to a 68. And then from here, grade 12, now we divide both sides by 17 because we must have only one base. 2 to the power x is equal to 68 divided by 17 is giving us 4. And then now we need a prime base so that this can be exactly the same. And then now same base equalize exponents. Then x is equals to a 2 there. And then now there is your activity grade terms. Let's see how far can you go. The first one is multiplication. The second one is the addition type. I am giving you 3 minutes to go through that one, and then we look at the solution thereof. Okay, grade 12, let's check now on your two activities now. The first one is multiplication type. Therefore, what must you do on the left-hand side? Grade 12, same base, we add exponents. X plus 1 plus x plus 2. On the right-hand side, you want to create the same base. It will be 3 squared for 9. And then now we end up with x plus x, which is 2x, and the 1 plus 2, which is plus 3, equals to 3 to the power 2. Happy now, 1 base on each side, and then now we can now equalize the exponents. So 2x is equal to 2 minus 3, which is minus 1. We divide both sides by 2, therefore x is minus 1. Number 2 is an addition type. That means it's a common factor type. So we start by doing what? Separating the exponents. Do you see the methods are not the same, grade 12? 2 to the power x and 2 to the power 2. And then we leave this 6 as it is. We'll attend to that later on. And then now, left-hand side, you have in common factor 2 to the power x. Take the common factor out. We are left with 2. Here we are left with 2 to the power 2, of which is 4, equal to 6. 2 to the power x, 2 plus 4 is 6, equal to 6. We divide both sides by 6 so that we can have a single base this side. And then 6 over 6 equals to 1. So we need the same base. We are going to write 1 is 2 to the power 0. Therefore, x is equals to a 0. Okay. And then now we move to the next topic. We are looking at sets. Remember, we have rules that we are applying on the set. The first rule is saying that if I am multiplying the same set, that means I can put this in a single set and write it as 2 times 5, of which is the square root of 10 for that one. Okay, done. And then number 2, again, I'm having the same set here. And then I can write this as a single set now. Okay, or I can write 21 in a simple set form. That means if you write this in a simple set form, you must write it as 2 numbers, multiply the other one must have a square root. Then that is 7 times, no, okay. We have square root of 7 times 3. When you are checking 2 numbers, you think of 9. 9, there's no way that you can have 21 multiplying 9 with something, okay? So now we are forced to write this. It is creating something that is similar to that one. As long as you can have something in common there, it will assist you. And then now in this case, we are having the square root of 7 multiplied by the square root of 3 multiplied by the square root of 3 again. So if you multiply these two, do you still remember the rule states that this will be square root of 3 squared, then 2 will cancel the root sign. We are left with 3 square root 7 there. All of them you are applying the set rules. And then with number 3, simple set form again. 75 can be written at least with this one. We have 25 having a square root. That is 25 times 3 there, plus square root 12 is square root of 4 times 3, and then minus the square root of 27, that is 9, square root of 9 times 3, it's a square root of 27. Can you see I've created square root 3 there? There must be something common created throughout. And the square root of 25, we know that it's 5. And then we are left with square root 3 in there. Square root of 4 is 2, we are left with square root 3. Square root of 9 is 3, we are left with square root of 3 there. Then now it's 5 square root of 3 plus 2 square root of 3, which is 7 square root of 3, minus 3 square root of 3. 7 minus 3, 4 square root of 3. That is how you solve that one picture. Number 4, simple set form. The square root of 48, you can have 16 times 3. So we'll write it as the square root of 16 times 3 minus the square root of 3. And then 27, we want to create square root 3, we say 9 times square root of 3 there. 9 times 3, sorry. And then from here now we can take out the square root of 16, which is 4, square root of 3, minus square root of 3, all over square root of 9 is 3, square root of 3. Okay, and then 4 square root of 3 minus 1 square root 3, it will be 3 square root 3 over 3 square root 3, of which our answer will be 1. It's the same as 100 divided by 100. A over A. The answer is equals to 1. And then now it's your activity grade 12. I am giving you 2 minutes to simplify, 3 minutes to simplify this one. We are having 3 of the sets. Simplify the following without using a calculator. Your 3 minutes start now. Okay, grade 12, let's see. The first one is saying square root 5 times square root 5 is the same as square root 5 squared, 2 of them, right? Plus the square root of 15 squared, the 2 will cancel root sign, you are left with 15. Same applies, the 2 will cancel the root sign, you are left with 5 plus 15, of which this will be 20. Done, that is your answer. Second one, you can see that those are difference of 2 squares, or you can use the multiplication that you normally use when you have 2 brackets. That will be 3 times 3, which is 9. And then 3 times square root 2 plus 3 square root 2. Minus square root 2 times 3 is minus 3 square root 2. Minus square root 2 times is minus square root 2 squared. And then this will be 9. 3 square root 2 minus 3 square root 2 will be a 0. And the 2 will cancel the root sign, then you are left with minus 2 there. 9 minus 2, it's a 7. That is your answer. And then number 3, we are having square root 50. You must write this in a simple set form. Then it will be two numbers, one having a square root, that is 25 times 2. 50 minus square root 2. And then square root 8 will be square root of 4 times 2, which is still 8. And then the square root of 25, it's 5. Then you are left with square root 2 minus square root 2 there. Square root of 4 is 2, square root 2. So on top, we are having 5 square root 2 minus 1 square root 2. Then you'll have 4 square root 2. And then denominator is 2 square root 2. So square root 2 into square root 2 once, and then 2 into 4 is only 2 times. That is your answer, grade 12. And then now logarithmic expressions. Now we are talking to logs. Do you still remember the rules that when you are adding, you multiply your logs? This will be written as a single log, and then this will be 2 times 5 now. And then remember, if there is no base, there's a base 10 there. If base is not given, you must know the base is 10. And then this is log of 2 times 5, which is log 10, base 10. Log of the same base is equals to 1. Log 10 base 10 is equal to 1. And then the second one, we are still adding now. We are having log base 8 there. Because of addition, therefore, we'll be applying multiplication. Our base is 8. It will be 2 times 4 there. And then single log of base 8 will be 2 times 4, which is 8. Log 8 base 8 is equals to 1. Okay, and then now we are having log 8 times log 32 now. And then we are going to separate this back to its original. That will be log 8 base 2. Initially it was plus, because here it's written as a single log, okay? Log 32 base 2. And then log 8 is the same as log 2 to the power 3. 8 is 2 to the power 3. So this can be written as 3 log 2 base 2 plus 32 is 2 to the power 5. Then it can be written as 5 log 2 base 2. Then this is 3 into 1 plus 5 into 1. Then this is giving us 8 as an answer there. So that is how you do your logs. Remember, we are applying the rules there. Okay, we are now coming to the subtraction now. We are having log of 40 minus log of 5. Remember, when you are subtracting, you write this as a single log of base 2. Because we are subtracting, it will be 40 over 5 then. That is the log of 8 base 2. And then this will be log of 2 to the power 3 base 2, which is 3 log 2 base 2. We are only applying the rules, grade 12. 3 into 1, the answer is only 3 there. And then the number 5, the challenge here, we look at the bases now, they are not the same. It's base 9, base 2, log 5, base 5 there. But we know that the log of 1 is a 0. For this part, we know the answer is 0 there. So now we'll concentrate on this 2. It will be equal to, if the bases are not the same, you use change of base method. It will be log 27 over log 9 plus log 0.25 is 1 over 4 over log 2 minus 0. You must indicate that 0, grade 12, to show to us that you understand that the log of 1 is 0. We want to see that 0. And then 27 in exponential form, it will be 3 to the power 3. Then it will be 3 log 3. And then 9 is 3 to the power 2. Then it will be 2 log 3. Plus 1 over 4 is the same as 4 to the power negative 1, of which is 2 to the power minus 2. So the log of 1 over 4 will be minus 2 log 2 over log 2. Then minus 0, we know it's a 0 now. You can just forget about writing it now at this level. Then log 3 will cancel log 3. We are left with 3 over 2 minus log 2 goes once there. And then we have a plus minus will be minus 2. And then 3 over 2 minus 2 there will give us a half as an answer there. So that is how you simplify that, grade 12s. And then your activity, we are having 2 problems there, and then let's solve them within 3 minutes, grade 12, and then we reflect back the solution. Your 3 minutes starts now. Okay, grade 12, let's see now, how did it go with this one? Now you look at the first problem, you can see that you are having, there's no base. If there is no base, your base is 10. And there's no way you can write 25 with a base of 10. So that means in this case, you just apply your rule of single log. This will be single log. And then with the base of 10, you know that there's a 10 there. And then now try to apply. If it is plus, it's a multiplication, then it will be 25 times 32. It's a plus, it's a multiplication, 27. It's a minus, then it's a division, 216. And then check now, when you multiply this and divide by 216, it must give you a log of 100. And then with the base of 10, this will be log 10 squared, 100 squared, 10 squared is equal to 100. Remember your base is 10 there. And then now these two move to the front, it will be 2 log 10 base 10. So we are having 2 into 1, of which the answer will just be a 2 there. And then now the next one, the challenge is the base is 3, is 6, is 7. That means the minute you have different bases, that means it's change of base method. So this will be log 27 over log 3 plus log 36 over log 6 minus half multiplied by log 49 over log 7. Continue now. 27 is 3 to the power 3. It will be 3 log 3 over log 3. Plus 36 is 6 squared. It will be 2 log 6 over log 6 minus half times log 49. 49 is 7 squared. Therefore, it will be 2 log 7 over log 7. Log 3 goes once into log 3, you are left with 3 plus log 6 once into log 6, you are left with 2. And then now minus half times log 7 once in log 7, you are left with 2 there. Then it will be 3 plus 2, which is 5, minus half of 2 is 1, then 5 minus 1 is a 4. So that is your answer, grade 12. I hope you got it correct. And then now we have logarithm expressions, activity. And then now let's look at this one, grade 12. We expected to have a log of 16 over the log of square root 2. And then now simplifying this further, 16 is 4 squared, or with base 2, it will be 2 to the power 4. Then it will be 4 log 2. And then square root of 2, remember, is 2 to the power half. Then it will be half log 2. So log 2, you are having 4 divided by half, which is the same as 4 times 2, which will give you an answer of 8 then. And then log 27 over base 9. Look at the base now, different bases. That means we must apply change of base. Log 27 over log 9 minus log 32 over log 16. Log 27, this one is coming more often. I think you now know that is 3 log 3. Log 9 is 2 log 3. 32 is 2 to the power 5. Then it will be 5 log 2. 16 is 2 to the power 4. It will be 4 log 2. Log 3 goes once there. 3 over 2 minus. Log 2 goes once in log 2. Then minus 4 over 4. And then 3 over 2 minus 4 over 4. And then this will give you 1 over 4 as an answer there. You go to your LCM and then apply the LCM. Then your answer will be 1 over 4. And then we have log equations. With log equations, we still apply the rules now. When you subtract, remember you divide as a single log. It will be x over 4 equal to a 2. Do you still remember the log method with exponent relationship, that you will be left with x over 4. This 10 will go there and form 10 to the power 2. Then it will be x over 4. And then 10 squared is 100. And then we cross multiply 4 to that 100. X will be equal to 400. Cross multiplication. And then with this one, because it's a plus, it's a multiplication, we are dealing with base 2, then we'll be having the log of base 2. Then it will be x into x plus 3, because we are adding, writing that as a single log. Then it will be log of base 2. We remove the bracket here. It will be x squared plus 3x equal to 2. Then now we have x squared plus 3x. And then this 2 will go this side and form 2 to the power 2. Then that is x squared plus 3x equals to 4, which is x squared plus 3x. 4 to this side is minus 4, equal to 0. Then you factorize. Factors of 4, when you subtract, you get a 3, that is 4 and 1. And then you share your x squared, xx. The middle term is plus 3, that means 4 must be positive and 1 negative. Therefore, x is equal to minus 4, or x is equals to 1. Then x cannot be minus 4, because the log of a negative number will be undefined there. And then now moving on to the third one is the multiplication and subtraction. There we are having the log of 2 base 2. So we apply our method of single log of base 10. If it's plus, it will be multiplication 2 times x. And then if it's a minus, it will be divided by 2x minus 1. And then equal to log 3. So because it's logs of the same base, yeah, we can say 2x over 2x minus 1 is equals to 3. And then now we cross multiply this to that one is 2x into 3, 2x minus 1. And then 2x is equal to 3 times 2x is 6x. 3 times minus 1 is minus 3. And then now we take 2 to this side. It will be 6x minus 2, which is 4x. And then minus 3 to the left-hand side is positive 3. Divide both sides by 4. Therefore, x is equals to what? 3 over 4 is your answer there, because 4 goes once into that one. So those are the logarithms equations. And then now, for the activity here, you were expected again to solve with the plus. Therefore, we will be writing this as a single log. You'll be having x plus 2 and then multiply by x minus 1 equal to 1. Multiply the bracket out, we have x squared. Remember, this base 10 will kick to the side and become 10 to the power 1. Okay, so we'll be left with the bracket this side, of which will be x squared, x minus 1, it will be minus x, 2 times x, 2x, 2 times minus 1, minus 2. So we end up with x squared minus x plus 2 is plus x minus 2. 10 to this side is minus 10 equal to 0. So that will be x squared plus x minus 12 equal to 0. Factors of 12, when you subtract together, 1 is 4 and 3. Then it will be x plus 4 and the x minus 3 equal to 0. Therefore, x is equal to minus 4 or x is equals to 3. A log cannot take a negative answer because it will be a log of a negative of which is undefined. And the second one we are subtracting, it will be log of x squared over 16 as a single log equal to 0. And then x squared over 16 will be equal to 10 to the power 0 there. Okay, then it will be x squared over 16 equal to 10 to the power 0, it's 1. Therefore, x squared to cross multiply, it will be 16. This side loses an exponent, this gains plus minus the square root of 16, which is plus minus 4. But the solution will only be x equals to a 4. X minus 4 is not a solution. And then with this one now, we have a challenge. Bases are not the same, but you can see here we can create a 3 from 9. Then it will be 2 log 3 base 3 there, minus log 81 base x equal to 4. So this will become a 1 because it's log 3 base 3. Then you have a 2 into 1 minus log 81 base x equal to 4. And then now we take 2 to that side. We are left with minus log 81 base x. 4 minus 2 will be 2 then. And then now we multiply with the negative throughout. Multiply with the negative throughout, you are left with log 81 base x. Then this will be minus 2, right? And then now 81 with x will kick that one to be x to the power minus 2. And then now we are solving for x. Then this will be 81 over 1 equal to 1 over x squared. Do you still remember that? Grade 12, that rule? So we are going to cross x squared to that side. It will be x squared equal to 1 over 81. Lose this exponent, gain plus minus the square root of 1 over 81, of which it will give us what? X is equal to plus minus 1 over 9. And then now the answer will only be a positive 1 over 9. You can't take minus as being the answer there. Okay, grade 12. And then this is your homework activity on all the work that we've been done. And then this is the exam type question structured for you on the expectations that you must expect as you've been assessed at the exam level. And then we wish you all the best, grade 12s, on this activity. Now you do it as your homework. And the summary of the content that we have done today, we looked at the exponents, multiplying and dividing, adding, subtracting, exponential equations. That means you must master all of that below the exponent. Under SURDS, you must know how to multiply, to divide, to add, and to subtract them. Under logs, you must know how to multiply, divide, add, and subtract. And you must also know how to solve the log equations. And the preview of the next lesson now, we will be having our just-in-time lesson on the 26th of March from 2 to 3:30, grade 12. And then the topic, we will be doing the revision on algebraic equations, where we will be solving for x on algebraic equations.